Today I'll be reviewing topic 6.2, externalities. But before we get into it, let's first have a small definition of what an externality is. In short, externalities are basically a side effect or consequence of an industrial or commercial activity that affects other parties without it being reflected in the cost of goods or services. Now, there are two types of externalities, one being positive and one being negative. Let's start off with the positive. Positive externalities are situations in which results the external benefit for others, thus meaning the marginal social benefit line would be higher than the marginal private benefit line. An example would be getting a flu vaccine or a COVID vaccine.
It is flu shot season, and I don't want to get sick, so maybe I should get it. It's free anyway. Damn, hurry up, bro. Thank you. Hey, Becky, look what I got.
I don't know. What?
I got my flu shot. Sheesh.
Sick. Now I don't have to get mine then.
What do you mean?
Well, I see you every day, and since everyone in the office has it, no one's really getting sick. Therefore, I'm not getting sick.
Ah, you're an idiot.
I do not support this advice. As you can see, that's an example of how positive externality works. By Fahim getting his flu shot or COVID vaccine, he is able to expand that marginal social benefit to others. Now, let's take a look at the graphs. Positive externalities. As with any graph, we start off with the axes, quantity being x and price being y. We begin to create a supply line that also equals marginal social cost. Then we create two demand lines, one being demand equals marginal private benefit, and the other demand equals marginal social benefit. Then we can begin to plot points. We label C because this is where the MSB is greater than the MPB. While society would like the firm to produce at point B, where the marginal social benefit equals the marginal social cost. Because this is a free market quantity, dead weight loss is created and is marked by the triangle ABC. Because consumers only take into account MPB of consumption, consumers will consume until MPB equals MSC. Now there is another type, as I mentioned in the beginning of the video, a negative externality. Negative externalities are situations in which the production or consumption of a product negatively impacts the third party. A simple example could be pollution. Pollution is an example because the polluter solely makes their decisions on the direct costs and the profit opportunity that they can make, instead of thinking about the third party and its indirect harmful costs. Now let's look at the negative externality graph. Negative externalities. As always, we start with our price and quantity axis. Then we create our demand line, which is also the marginal social benefit, which is the satisfaction experienced by consumers of a specific good. Then we add the marginal social cost, which is the cost that society pays as a result of the production of additional units. At the same time, we add our supply line, which is the marginal private cost, which is the additional cost to the firm of producing one more unit. And as you can see, the MSC is greater than the MPC, which is marked by the triangle and also labeled dead weight loss. Thus meaning society is experiencing more costs than the firm at that quantity. Thus, a firm always produces when QD equals QF. Therefore, society would like the firm to produce at a social optimal point where MSB equals MSC. So you might be wondering, are there any solutions to both of these situations? The answer is yes. Both answers include Pigovian taxes and subsidies. For negative externalities, a solution would be imposing a per unit tax on the production. And here is the graph to explain a little bit more. Negative externalities per unit tax. In order to fix the negative externality, the government will impose a per unit tax on the good or service. Thus, this tax will have MPC, or supply 1, shift up and to the left until it equals supply number 2, or MSC. As a result, it will remove the externality and force production to be at its socially optimal quantity. And because a negative externality causes overproduction, a tax cuts back production for a good cause, which can also be called the Pigovian tax. For positive externalities, it would be best to impose a per unit subsidy, which is shown here on the graph. A positive externality and per unit subsidy. Once it comes to a positive externality, the opposite rules apply. Because a positive externality suggests underproduction, the government needs to encourage production with a per unit subsidy. Thus, with a per unit subsidy, it will shift the MPC down and to the right until it produces at a socially optimal quantity. The per unit subsidies could be labeled as followed: QE for quantity equilibrium, PE for price equilibrium, while PC is the price paid by consumers and QO is the socially optimal quantity, while PS is received by producers. And as you can see here, the subsidy shifts down. So now that we're nearing the end of the video, I'm going to give a practice MCQ to see kind of where you're at understanding the topic. When consumption of a good generates a positive externality, which of the following must be true at the market equilibrium? Feel free to pause, as in the next second I will reveal the answer. The correct answer is B. Well, that's all for me. I hope you learned something new, and thank you for listening.